Okay, let's do this. So today we're going to talk about digital images. Now, that means way before Photoshop or any other program we're going to work with, I want to make sure that we understand what's going on, that we have a common vocabulary of what's happening around us. This is really important. Almost every piece of software that you're going to use uses vocabulary, it uses terms, it uses concepts that it assumes that you know. Matter of fact, it really doesn't assume that you know them at all, but the more you know about the little bits and pieces that go behind things, the better off you are. So you don't have to take notes, you don't have to do anything, you just need to understand what's going on, because the more you know about this, the easier the stuff is going to be later on. And I've got a lot to cover, and I'm going to cover it quickly because let's do it. So let's start off at the very beginning. There are really two schools of computer graphics. The first one is called raster-based computer graphics or bitmap-based computer graphics. Now, when you're dealing with a raster or bitmap-based computer graphics, you're dealing with what is basically graph paper graphics. So if you come over here, and if I were to draw a grid, right, here we go. Not the world's best grid drawer, but there it is. I were to come over here and draw a grid. Now, if I want to draw a circle on that grid, let's come over here and give myself a nice purple circle. That means I would have to fill in the dots, right? So I go dot, 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 dot. Beautiful. Well, not really beautiful, but it's a circle. Well, it's circle enough. It's the best circle that I can make with this technology. If I want a better circle, I need more dots on a bigger grid. And almost everything that we're going to be doing in the next few workshops is basically going to be dealing with this concept of dots on a grid. But I want to be clear, there's an entire other type of computer graphics out there known as vector-based computer graphics. Now, vector-based computer graphics for many years really only existed in very particular arenas. The thing about it is it's opened up enormously. Now, the thing about this is that if you like math, and I know you like math, if you like math, the equation of a circle is very small. If the circle was the size of a grape, well, orange, or the circle was the size of a planet, the equation of the circle would be equally as small. And basically, what do we know about circles? There's a center point, and there, oops, let me come over here and grab that. There's a center point, and there is a radius, and there's a circumference. And the cool thing about the equation of a circle is that, again, no matter how big the circle is, the equation stays small. Now, vector-based graphics basically save, instead of dots on a grid, a series of equations. Now, could you define me as a series of equations? Not readily. Though I did once have a professor who was a geneticist who's like, well, technically, but that's not what we're talking about. The idea is that people who use vector-based graphics tend to be people who do things like Illustrator or illustrators or things that are drawing or drawn or CAD. Anything that's truly computer generated. The world in which we live tends to be photographic. We tend to try to take that world as if we look through a screen door and then, put dots on a grid. But if we're dealing with things that are what we call born digital, where they're really dealing with the computer world, then vector-based graphics is a thing. I've got several examples of vector-based graphics. My favorite, by the way, is a vector-based drawing program you use almost every day, and that would be Microsoft Word. So if I were to come over here and I were to draw the letter E, notice I didn't say type the letter E, I said draw the letter E. Now, as you know, I can highlight this and I can say 72 point. But have you ever typed in a bigger number, like 360? That's right. You can keep typing in larger and larger numbers here. And what you'll notice is that the E still looks good. Matter of fact, let's see, can I make it even bigger? Let's go with 450 points. Look at that. And so the idea is, because this E is made up of a series of equations, in this case what's known as a true type font, or which is a vector graphic, because of this, it basically says there's a line, there's a line, there's a curve, there's a line, and every time you draw the letter E, you type letter E, it redraws it, and you could zoom in and you can make this as big as you want with no limit. Now, you're like, wait a second. If you look over here, you're going to start seeing jagged edges. Those jagged edges that you see are not actually in the letter E. You have to understand is that the display we're using, the monitor that you're viewing this on, is made up of dots on a grid. That technically these are raster-based devices. So you've got a bitmap-based device, which is your screen, and then you've got this vector-based image, which is the letter E, being drawn on it or being rendered on it. So when we deal with this hybrid of what it's like to take something from one format to another, to overlay text on an image, is to put a vector-based image on top of a bitmap-based image. Crazy little vocabulary there, but it makes a difference as we move forward. The other thing that comes up is, all right, so great. So you don't need to know about fonts. Fonts are all vector-based. They scale beautifully. I'm not in the business of designing fonts. I just use them. Well, there are a lot of people out there who do things that are very much graphic related. If you ever worked with any laser cutters want, of course, to be able to create shapes. And so they use vector-based graphics. CNC machines, computer-controlled cutting machines, also use vector-based graphics. So you're going to see people using things like Illustrator or CorelDRAW. And one of my favorite is there's a toy. And if this was an in-person class right now, I would pull it out. And it's called the Crayola Doodle Penguin. Well, it turns out I found a video online of the Crayola Doodle Penguin in action.
Hello, I'm Doodle Penguin, and I'd love to draw with you. Let my flippers help you pick a drawing. Pop in a Crayola pen, press my tummy, and then, whee! I can draw pictures, dot to dot, learning fun, and mazes. Come on, let's colour and play. Crayola, everything imaginable. Doodle Penguin.
They no longer sell the Doodle Penguin, by the way, and we're better off for it. I love when I show it in class. It is so slow. It's like 6 minutes to draw anything. I always joke it's the toy that teaches your children patience. But the idea that it's vector-based drawing, and anything that drops a pen and draws a shape and lifts the pen, you're seeing a lot of toys like this that is vector-based, versus the idea of every line, every dot, grid-based dots on a grid. And so again, I want to focus back on raster or bitmap-based computer graphics, because that is the world in which we live. Haha. We continue. So let's start talking about our vocabulary. The smallest unit in computer graphics is called a pixel. A pixel is the smallest unit that we work with. Now, it is short for the word picture element. Picture element basically means a piece of a picture. Now, I want to be very careful here that when I use the word picture element and pixel, people also refer to it as a dot. Let me come over here and say that. Type for me. There we go. AKA a dot. But technically, this is not true. There is a difference between a pixel and a dot. And I want to explain it really fast, and we'll explain it in more details later on. But basically, people ask me all the time, they go, Jared, how big is a pixel? And I say, a pixel is. It's a unit of measurement. It is a unit of measurement. Pixels measure data. A dot is a pixel in physical form. If you can measure the dot, if you can hold a ruler up to the dot, then it's a real piece, and it's a dot. So on the screen, I'm going to jokingly magnify one. On the screen, that is a dot that represents 1 pixel's worth of information. Again, we're assuming that we've zoomed in here for a second. So again, pixels exist inside of the computer, but a dot is a pixel in physical form, whether it's, again, on the screen or on paper. If you can measure it, if you can hold up a ruler to it, then it's a dot, and that dot is a pixel's worth of data. Do we use the two terms interchangeably? Absolutely. But I think it's good for you to know the difference between pixels of information and dots, again, on screen or on paper, because later on there are going to be little differences in between, and worse yet, we're going to mix up some of our vocabulary. Don't blame me, I'm just the messenger. All right, so again, pixels, and I mentioned that we had a grid. The grid is actually something called resolution. Resolution. And resolution is the number of pixels wide something is, pixels wide, by pixels tall, also known as width by height in pixels. Now, one of the things that confuses people is that if you think about art for a moment, the numbers are reversed. If I were to tell you that you had a photograph that was a 4x6, you'd be thinking 4 inches tall, 6 inches wide. But in computers, we would call that a 6x4 because it's 6 inches wide and 4 inches tall. So it always confuses people. Why is it one way versus the other? Well, you have to get here is that computer graphics are based on math. And of course, we always started with the number line, right? The number line. So we always started with the width, and then we later on added this direction so that we ended up getting the height. So that's why it's width by height, because width is priority and height is secondary. So I know why in computer graphics is width by height. I don't know why in art, why it's height by width, but that's not important today. What's important is to realize it's width by height. And then lastly, do not forget this last bit, which is in pixels. We have to be very careful that whenever we have these discussions that we do not leave out our units to know that we're talking about. If I say 4 by 6 what? And again, or 640 by 480, 640 by 480 what? I'm talking about pixels, because there are other units we can be measuring in, and it's right now it's only going to be pixels, and that's what I want to talk about. So we have the grid, which is resolution, and we have pixels on the grid. Now, some people are going to use the word, you're going to hear the words DPI come up later on. DPI, and they're going to go, what's the resolution? And someone's going to say 300 DPI. That is a misnomer. DPI and resolution are really two different things. Even if Adobe tells you they're the same, they really aren't. For our purposes, DPI means something else, which we will get to. But right now, I want you to think about resolution as the absolute number of pixels that you have. If you've got 1,000 pixels by 1,000 pixels, that's your resolution. So far, so good? Let's continue. So in addition to this idea about pixels on a grid, we have one other piece that is really important. I wish you were here right now for me to ask this question. And that is, I'd like you to look at the screen for a moment and say to yourself, what is the shape of your screen? I can hear you answering it right now. You're going to look at your screen and go, it's a rectangle. Very good. Then I'm going to go, what is the shape of the rectangle? At which point you make this great little face. You're like, and the reason you make the faces is because you don't know how to answer the question. Because to answer that question, you need another vocabulary term. Because remember, rectangle is a vague term. Rectangle is extremely vague, right? Because a rectangle could be this, or a rectangle could be this. They're both rectangles. Now, if I were to come up with a perfect rectangle, that would be, ooh, look, that's a square. We have a special name for that. So what we're talking about here is a different term, and that term is called the aspect ratio. And the aspect ratio is the relationship between the width and the height. So the aspect ratio of a square is 1 to 1. And by the way, if you're using a standard computer monitor, the aspect ratio that you're looking at is 16 by 9. So that's what you're looking at. Older computers had an aspect ratio of 4 by 3. Now, the aspect ratio can be gleaned from the resolution. If you know what the resolution is, you can obviously calculate the aspect ratio. But talking about the aspect ratio is important. Why it's important is because in the early days, when we talked about resolution, we had different resolutions. For instance, we had 640 by 480. Then we had 800 by 600. Then we had 1024 by 768. And while if you look at these numbers, while they look different, they actually all have the exact same aspect ratio of 4 by 3. And so for years, what would happen would be is the computer monitors wouldn't change shape, but they would change resolution. What's even more important here is that the resolution of the display and the aspect ratio of the display have nothing to do with the size of the display. The size of the display is relatively arbitrary. Your computer monitor that you're watching this on could be, you can be watching this on a phone that's this big, or you can be watching this on a giant screen that's this big, because the number of pixels and the shape of the screen are independent. What would be different is the size of those pixels, which, if you noticed, isn't even mentioned, because the size of the pixels isn't as anything to do with it, because remember, pixels don't have size, dots do. So the size of the screen is irrelevant. It's the number of pixels. Remember, 1024 by 768, 800 by 600, 640 by 480, all have to do with how large those pixels are or how dense those pixels are on the screen in front of you. But again, regardless, they all have the same aspect ratio. Now, a lot of the reasons I have this conversation with you is because a lot of what we've done is sort of the Wild West of what used to be. Now, don't shoot the messenger here, but there are really some weird vocabulary terms that we run into. And the reason we have weird vocabulary terms is there are two evil people out there. One of them is marketing people, sorry, Mom, and the other are computer scientists, sorry, everybody else. And the idea being is that computer scientists and marketing people love to mess up the way that you and I try to talk plain speak about what they do. And because the terms have become industry terms, we need to sort of at least have an acknowledgement of what it is that we're looking at. So let's come back to the 640 by 480. Well, computer scientists, oh, look at that. It did the math for me. Look at how clever is that? 640 by 480 used to be called VGA. Actually, it's still called VGA. And 800 by 600 was called SVGA. And 1024 768 was called XGA. The idea being is that they would come up with these standard terms for what these were. And if you were buying a monitor or if you were buying a video card, it would say VGA, SVGA, XGA. And these terms, by the way, are still used. You will still see them when purchasing, for instance, a projector where things make a difference there. By the way, when buying a projector, the resolution isn't what's important. Partly what's important, it's the lumens. And there's always something else. If anything you should walk away from when we're having this discussion is that there's always something else to look at. There's always some little bit of detail that you're like, I'm looking over here at this statistic, but I should be looking at all of them to make it better. All right. So why is this so important? And why don't we use these 3 or 4 letter acronyms to describe resolution anymore? Well, let's talk about the marketing people for a moment. When digital cameras first came out, one of the cooler things was, I remember buying one, teeny little thing, paid all this money for it, and it didn't have the resolution on it. What it said was QVGA. Well, I bought it. I didn't know any better until I got home and I plugged it in, and I found out that QVGA stands for quarter VGA, so which is actually 320 by 240, which means I got screwed. That happened a lot. And so because these became industry terms but not standard terms, we need to come up with a better way of understanding these things. Now, for a while there, digital cameras weren't useful in print, and we'll get to that a little bit later on. But the first major camera that had an impact in print was one that was 1280 by 960. 1280 by 960 was the first camera that you could really get a good print out of it. And so the marketing people were like, 1280 by 960, well, how many pixels is that? And you're like, oh, look at that. It's 1,228,000, screw it, we'll call it 1.2 million pixels, or megapixels. That's right. A megapixel is not, that is a megapixel, a really big pixel. No, a megapixel means a million pixels. So if you multiply the width by the height, you get 1.2 million, and so you got 1.2 million pixels. And what you found in the early days was that 1 megapixel gave you a good 5 by 7. 1 megapixel gave you a good 4 by 6. 2 megapixel gave you a good 5 by 7. And 3 megapixel gave you a good 8 by 10. And you're like, then why the hell do I have a 20 megapixel camera? That's a good point. Well, I do have a 20 megapixel camera. What are you doing with all those pixels? Remember, even if I were to look at this, my screen right now, I think it's set to 1920 by 1080, right? That's 1920 by 1080. That's only 2 million pixels. If my screen is only 2 million pixels, why do you need a 20 megapixel? It's a good question. One reason, by the way, is because you can crop. The nice part of it is I can take a picture of a squirrel in a tree, and I can cut that little squirrel out. And the other is so you can print nice and big, which, again, we'll get to later on in one of our further little discussions. The idea being, though, is it allowed you to compare apples to apples. If you were to look at cameras and say that's a 2 megapixel camera, that's a 3 megapixel camera, it does allow you to do a generalized comparison. Now, the dangerous part is when you multiply the width by the height, you do get this number of pixels, but you lose your aspect ratio. The entire thing I just started this part with, this entire screen, is dedicated to aspect ratio. In the early days, this was a problem because literally the cameras all took different shaped pictures. Nowadays, they don't. They're standardized, so it actually is fair to compare one to the other. The other thing that I love to point out here, kind of a fun one, is I have a camera that is 4,000 pixels by 3,000 pixels. So you would think to yourself, how many megapixels is that? 12! Then why does it say 12.1 on the box? Weirdest thing here is that marketing people do love to lie. A friend of mine tells a great story about some guy who climbed a mountain. First time to climb the mountain. They always bring all this technical equipment with them up to the top. And when he climbed the mountain, they said, how high was it? And he was like, 37,402. Well, later on, somebody analyzed his data, and it turns out it wasn't 402, it was 400 even. And they said, why did you lie? Why did you add those extra 2 feet? And he said, because if I gave you a round number, you would think that I rounded. It's a strange thing. But I want you to think about the nature, human nature with numbers. And that is this. If I tell you that my hometown is 47,312 people, you're thinking, wow, that's exact. But if I tell you that my hometown is 47,000 people, you're thinking, wow, must have been a round number. And so there's something to be weird about this. Plus, there's that whole marketing, if it ends in a 9, you'll buy it. $1.99 versus $2. Boy, when I explained it to my 8-year-old, she was like, everything costs more. I'm like, yeah, welcome to the club. The idea is that you should realize that if you were to open any digital image coming from a camera, coming from a scanner, or born digital somehow, if you had a digital image, it would have a grid. It's basically a grid because everything's a grid. The grid is the resolution. The shape of the grid is the aspect ratio. The size of the grid is basically just the resolution, because remember, the size doesn't exist in the real world. It's only the number of pixels, which haven't been materialized yet. And the pixels are the smallest unit computer graphics that we can control. So again, our basic starting point is pixels, resolution, aspect ratio, and lastly, megapixels, or really big pixels. And now we'll move on to my favorite of all discussions, and that is color.